Welcome to The Explainer. Today we are completely pulling back the curtain on computation and breaking the fourth wall. We have to ask a totally meta question. Is the artificial intelligence you're watching right now built on an absolute, deterministic truth? Or are you just experiencing a probabilistic facsimile of intelligence? To figure that out, we're going to look at a massive, hidden conflict happening right now at the very core of modern computing hardware.
Here's our roadmap for today as we descend from the fuzzy illusions of software straight down to the bare, unyielding metal of physical silicon. We'll hit the computational illusion, the FPU gambler, fax machine decay, the ALU surveyor, the divine script, and wrap up with true hardware fidelity.
Let's kick things right off with Section 1, the computational illusion. We really have to ask, do computers actually process meaning? Think about it for a second. When you type a prompt or ask an AI a super complex question, we just intuitively feel like the machine gets it, right? Because the output makes sense to us, we assume there's actual comprehension going on. But beneath that shiny, user-friendly interface, the hardware is completely blind to meaning. It doesn't know what a symbol is. It doesn't understand context at all. Literally, all it registers is physical resistance and strict, clocked voltages flowing through metal pathways.
So, we've got this massive, profound gap. On one side, there's our organic minds, what the source material calls OS alpha. Human minds are fuzzy, continuous, highly associative, and deeply driven by context. But the hardware, the actual silicon chip, it operates purely on strict, deterministic logic gates. It is driven entirely by microscopic switch states. And bridging this massive gap between the fuzzy, continuous nature of our minds and the rigid, binary states of silicon, well, that is the grand tension of modern technology.
Okay, let's look at the reality of this gap in Section 2, the FPU gambler. This is the hidden flaw in modern AI hardware.
80 to 90%. That is a staggering number, and it actually represents the percentage of modern AI compute cycles that rely on hardware-level approximations, not exact math. When these large language models are doing their incredibly heavy lifting, they're mostly using FLOP processors, floating point operations. And here's the wild part. These components fundamentally just guess the nearest mathematical truth rather than calculating an absolute verified reality.
Meet the culprit behind this giant guessing game, the FPU gambler. When the floating point unit hits complex math, it essentially throws darts at a dartboard to approximate answers really, really fast. And to make it worse, chip manufacturers literally burn secret proprietary seed tables directly into the silicon to help it guess. Which means, practically speaking, an ARM chip in your phone and an Intel chip in a server might actually give you slightly different results for the exact same equation. Sure, it's incredibly fast, but because of those hidden seed tables, it is entirely unaccountable to exact mathematical reality. And because this foundational math is basically just an educated guess, we hit a massive structural crisis. That brings us to Section 3, fax machine decay and the wood chipper effect of data.
When the FPU gambler approximates data, it permanently wipes out the exact identity and provenance of the original inputs. Think of it like a giant blender. You know exactly what fruits went in, but there is absolutely no way you can reverse engineer that smoothie back into its exact original components. Without what's known as Shannon correction, which is essentially a way to mathematically guarantee a signal transmits flawlessly from point A to point B, we get compounding facsimile noise. With every calculation, the truth just gets progressively blurry.
This creates a really severe modality gap. Inside an AI, concepts exist in these smooth, continuous vector spaces, but digital hardware requires rigid, discrete chunks to operate. So the system literally violently crushes those smooth human concepts down through text tokenization. Honestly, it's exactly why AI is famously bad at math. It memorizes math as arbitrary text strings instead of actually using decimal logic. And as these FPU approximations just compound over millions and millions of tasks, the data deeply degrades. The facsimile noise totally takes over.
So, if the FPU gambler is destroying our ability to maintain truth, how do we fix it? That's Section 4, the ALU surveyor, and a return to exact deterministic truth.
We literally have to deliberately shift our operations away from the gambler and embrace the arithmetic logic unit, or the ALU surveyor. While the FPU is fast and lossy, the ALU deals strictly in universal, undeniable truths. It guarantees that 1 + 1 is exactly 2, every single time on every single machine on the planet. Yeah, it might be slightly slower on that initial calculation, but knowing the math is completely absolute makes it perfectly, forensically accountable.
Notice how this exactness plays out visually here, a stream of discrete pulses.
literal ones and zeros, just marching forward. The ALU operates exactly like this: precise, discrete, totally predictable. There is no guessing going on here at all. No proprietary seed tables manipulating the outcome behind your back. Just pure, verifiable logic that you can trace back to the source every single time.
So how do we actually cross the gap from our messy, probabilistic minds to this strict ALU surveyor? We'll cover that in Section 5, the divine script, and the semiotic bridge of text.
We use text, but not just casual text. We're talking rigidly structured text acting as a universal interface. The sources actually call this a semiotic bridge. By using explicit, highly regimented formats, like JSON or Python code, we create a lossless, zero guesswork translator. We call this structured code the divine script, because it's literally the only thing that allows us to command physical hardware with absolute lossless precision.
Following this path of perfect intent, we can see the full sequence play out. Step 1. The human pilot imagines an associative concept. Step 2. We formalize that intent into rigid text. Step 3. That text forces the ALU into exact mechanical state transitions. We are quite literally tricking rocks into thinking using lightning, which, when you really think about it, is absolutely wild. And text is the only steering wheel we have to do it.
And that brings us to our final section, true hardware fidelity, and the ultimate choice of authorship. This is where we finally take back control from all that probabilistic noise.
By actively wielding this divine script, we achieve true ALU fidelity, and the benefits here are massive. It totally eliminates the hidden guessing of the FPU. It restores our ability to prove a mathematical chain of title, bypassing all that clunky bloat of visual interfaces. And maybe most importantly, it enforces a human moral mandate over the machine. We can safely compile our actual human intelligence directly into silicon without having to rely on degrading facsimile noise. I want to leave you with this final provocative thought. As our systems become exponentially more powerful and deeply integrated into our daily lives, the choice of authorship is entirely yours. In a world increasingly run by lossy statistical engines, will you wield the divine script to command deterministic truth, or will you just settle for a facsimile of intelligence, letting probabilistic noise take control while you act as nothing more than a moral crumple zone? Really think about it. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you next time.